doing the lectures, it's super unusual to see first 3 rows without any people. You can distribute a little bit if you want. Okay, it's like everybody sitting on the back and cheating, just reading some stuff. Yeah, okay. So, I'm ready. You can start. That's a nice move. Okay, hello everybody. Thanks for joining this talk. My name is Shevchenko. I'm the CEO of AURORA Labs, the company that is developing AURORA solution. But my talk today is not going to be about AURORA. I'm not here to sell you AURORA as a project. I'm not here to sell you part of our project, which is Rainbow Bridge. I'm here to share with you the knowledge about how to build bridges properly and what problems are there, right? So I'm going to begin with a simple thing, a schedule, like the agenda here, right? I'm going to talk a little bit about the bridges itself, what are the problems they have. Then we are going to transition into the architecture of the Rainbow Bridge, how we build it. Then we are going to talk a little bit about the governance and what hurdles it have, and then go into practical aspects and then obviously into open problems. There are lots of things to cover, so yeah, I believe you will have lots of questions, right? So let's start with the first piece, with the introduction and the bridges itself. Can you raise your hands if you ever have tried any bridges, right? And you understand what it is? Okay, quite a lot of this. So maybe for you, this slide will not be actually very important or informative, right? But just for everybody else here, yeah, for you just to know what is the bridge, this is the slide, right? So you know that the blockchain is a sandbox solution. This is a solution inside of itself. It cannot communicate with anything outside, right? You cannot just put in the smart contract. There is no such function in the Ethereum SDK to call the API that is outside of the Solidity sandbox, right? You cannot do it, and there is a strict reason for this, right? You need to have the consistency. All of the data, all of the execution needs to be consistent, right? So you cannot overcome this. This is the core of the blockchain. So the bridge is a solution to connect the sandbox to something that is located outside of it, right? In case you would like to query some APIs, you have Oracle solutions, right? And if we're talking about the bridges, this is the solution that connects blockchains in between itself, right? So in generally, when we're talking about bridges, people are thinking about token bridges. So there is an ability to send tokens from one blockchain to another blockchain, and yeah, this is the token bridge. Quite recently, there are additional bridges that get developed. They usually called as generic bridges, which allow to transfer any data. And by transferring any data, I mean that some kind of execution of some kind of transaction, right? So you're executing the transaction, you've got the execution results. It can be some kind of log from the transaction, right? It can be an event that is emitted. And then you're able to move the data from that event to the other blockchain. There are lots of existing bridges, and Rainbow Bridge is not far not the first one, right? You probably know many of them, and as we also you have been trying it, right? The ordinary architecture of this bridge works the following way, and I'm going to talk about the token bridges. On the source chain, on the chain from which the transfer is happening, there is some kind of escrow account. So what you need to do is to move your funds into the escrow account. And then there is some kind of entity that is responsible for bridging the tokens. And this entity, it actually monitors the balance of this escrow account and tries to understand who was sending the transaction and who was sending tokens to this escrow account. And obviously this entity may be just a single entity, or it may be multiple entities together, combined together into some kind of set of the participants. Some of the networks are calling this set of the participants the bridge validators, right? And as soon as the entity is seeing that tokens were transferred to the escrow account, they agree on issuing the IOU tokens, right? Or like a digital certificate on the other chain. And for this, they are calling so-called minter contract, right? So they're able to mint additional tokens on the other chain. And obviously the problem of this approach, and this is like the ordinary architecture, most probably if you haven't ever used Rainbow Bridge, you have been experiencing absolutely this architecture and you have been using it. And the problem is obviously in the middle. The problem is these bridge validators. Because what you're doing literally with these transfers is actually you're transferring your tokens to a multi-sig wallet, right? So that's it. That's it. You're trusting all of your funds to this entity or entities. And well, in some cases, in the market right now, there are bridges that have millions of bridge liquidity, more than like tens and I believe even hundreds probably. And the thing in the middle, the entity in the middle, is just 2 or 3 multi-sig, and all of the 3 keys are kept inside of the same company, right? So obviously there might be not a very big incentives for this company to cheat, but in general your protection as a user, as an owner of these assets, is not that high. And well, the core problem is just the centralization of the solution, right? And we are here, you know, all of us sharing the vision of the Ethereum community, right? Of the decentralization, trustlessness. So that's the question. How we can do it better? Is it even possible to do it? And the answer here is yes, you can do it, but it is damn hard to do it. It's just super complicated thing. It is absolutely on the other level in comparison to the multi-sig approach that is implemented in many other solutions. And yeah, we did it. And like, it's not even me, it's the team. And I was actually joining the project like in the last phase of it. Yeah, I just needed to wrap everything up. So all of the credits to the AURORA team. And one additional thing I want to talk a little bit, because like rollups right now also is a pretty hot topic, and bridges are also, you know, connected with rollups. You need to move your funds, or you need to move your tokens to the rollup in order to be able to use that inside of the rollup. And the difference here is that these rollups may or may not use the blockchain underneath it. But in the end, what they have is they experience in the security level of the source chain. This is what they are building on top of. So that's why the transaction finality, or the finalization of the transaction in rollups, is dependent on the connection of the rollups to the source chain. And in this case, the finalization may take some long period of time. It can be, like naturally for many rollups, it is a week, something like that. So still, you can move token, and this is obviously true for the transfers of the token from the rollups back, right? So in case you are doing the transfer to rollup, again, you're depositing your funds somewhere. This can be as fast as Ethereum can give you. So as fast as the finality of Ethereum transactions, which is also an empiric thing, right? You can have like 10, 20 confirmations, what is okay for you, or what is okay for the rollup itself. But then after it, you need to bring money back, or bring your tokens back, and it can take up to 1 week. So long story short, there is a problem. Let's try to solve it. And Rainbow Bridge is the answer, or the architecture of the Rainbow Bridge is the answer to this problem. Now, this is a pretty complicated slide. This is only, you know, the tip of an iceberg of the architecture of the Rainbow Bridge. And we are going to go a little bit deeper into it in just 1 minute. But for those of you who are deep enough in the blockchain, on the tech side of the blockchain, just 1 minute pitch about the architecture of the Rainbow Bridge is that it literally implements the light client of the source and target networks as a smart contracts on the opposite networks. And because of these light clients, we can get an ability to prove the inclusion of the transactions on the other chains. Just absolutely as your wallets are doing. And and because of this, we are able to understand that something was deposited in the escrow contract. And that's why we need to mint something on the other side. Now, this is the high-level architecture. But let's go a little bit deeper. So first thing that we have in the Rainbow Bridge, and I was talking before about the source chain and target chain, just for the generic bridge. But Rainbow Bridge right now is implemented in between Ethereum and NEAR blockchain. And just 30 seconds pitch of NEAR. This is a Gen 3 blockchain with a proof of stake and horizontal scaling implemented through the sharding, dynamic sharding. So we have two blockchains, and what we do first is implemented light clients of Ethereum and NEAR as smart contracts on the other chains. So literally on NEAR blockchain, there is a smart contract that does validation of ETH hash, right? And on the Ethereum blockchain, we have a light client of NEAR that does the validation of NEAR consensus, right? And because of the way how these light clients are implemented, and because of some restrictions that developer SDK is imposing on us, Ethereum light client on NEAR is implemented as realistic light client, which means that as soon the block committed there, it means that it is available, it is final, right? Obviously, depending on all of the rollbacks that are there in the Ethereum blockchain, right? So if you have, I don't know, like 10 confirmations of the block in the Ethereum light client on NEAR, then it means that more or less this block is final. While NEAR light client is implemented as an optimistic light client. And the reason for this is that NEAR blockchain has a proof of stake consensus. So everything ends up into checking the signatures of the validators. And the signatures of the validators, since NEAR is using ED25519, which is Edwards curve cryptography, it is hard for Ethereum to validate. Because Ethereum native cryptography is SEP keys, right? And there is the EIP 665, it is already 4 years under considerations whether this needs to be included. And unfortunately, it is not yet there. That's why there is no host function for validating this Edwards curve signature, which means that there is no simple way to validate the signature. And unfortunately, this needs to be implemented as a smart contract. And we are these crazy guys who implemented cryptography by ourselves, and not even the cryptography itself, but also as a smart contract, right? It is 1,600 lines of code, generated absolutely unreadable by ordinary, normal human. It is generated by the program, right? So specifically for this, we needed to implement it as a smart contract. And obviously, since it is a smart contract, it is super expensive. We cannot run it every time with, at the moment, 60 validators that NEAR blockchain is having. So we just cannot check it all the time. That's why when the block is committed to the NEAR-like client on Ethereum, and again, Ethereum fees, you know. So every time the block is committed, it is stored in the so-called untrusted state, and only after some period of time, in case the challenge was not issued, then this block is treated as final. And who is able to issue the challenge? Well, we have for these relayers and watchdogs, right? So these are the services that are running outside of the blockchain and doing pretty simple stuff. They need to keep the networks synchronized, right? So there is a relayer that is sending Ethereum blocks to NEAR blockchain directly, the headers obviously, right? And then the light client is verifying the ETH hash and all of this stuff. And there is the other relayer that is sending NEAR blocks to Ethereum, right? And the challenge is issued by the watchdog, the service that actually checks whether the submitted client is okay or not. And in case there is some kind of, and everything is verified in the NEAR light client except for the signatures. It takes about 1.5 million Ethereum gas for the validation of one block. But even a single signature costs some hundreds of thousands, and we just cannot check everything. So in case the watchdog is issuing the challenge, then the particular signature gets verified. But what is the economics behind this? Well, we need to introduce here, we need to incentivize watchdog's existence, right? We need somebody to run a server and constantly checking what are the blocks that were committed to NEAR like client on Ethereum, right? And we need to understand and like issue the challenge, which is also an Ethereum transaction that costs some money, right? So how we would do this? Well, literally, we are saying that if you want to become a relayer, you need to stake a little bit of ETH on the Ethereum side, right? And then in case you are committing wrong information, then the watchdog will issue a challenge and you are going to get slashed. So you will not be able to retrieve your deposit. Okay, so a little bit more complicated stuff, right? But now let's go deeper. So we have the setup of the synchronized blockchains through the light clients. How we're going to use it? For this, you need to convert it into a service. We have prover contracts. And these prover contracts, they are simply answering the following question. In case this is my transaction, was it included in Ethereum blockchain or was it included in NEAR blockchain? So this is just literally a service or like an interface to the light clients, right? And things that you are able to prove with provers is actually anything that you are able to prove with the ordinary light client, right? Because it has the information from headers. So for example, for Ethereum prover on NEAR, you can prove things like the inclusion in trie, and you know that there are 3 tries, right? The try for transactions, the try for logs, and the try for storage, right? So anything that is located in these 3 places, you can prove. You can prove potentially the height of the blockchain. You can prove some kind of timestamp of the block. You can prove stuff like that. So anything that is provable can be proved. And on with the NEAR prover, obviously similar things, but because of the specifics of how the blocks are constructed, you know, they are a little bit different. But in general, anything, again, just bottom line here, anything that can be proved in general in the blockchain, it can be proved through the provers, right? And a good thing is that obviously that we have not built all of the potential provers. Many of the provers are just not yet there. We just do not have, you know, the capacity to prove everything that can be proved, right? And the good thing is that, well, light clients are there. Watchdogs and relayers can be set up, and they set up by us, but anyone is able to connect there, right? But then provers can be developed by anyone. This is just the smart contracts that are sitting there in the blockchain. You can access them. You can access the information that is there, right? So absolutely no problem in doing this. And even more, what's the reason for you to have a prover? Well, actually, you need to do some kind of logic on top of this information. And this logic is incorporated inside of what we call connectors, right? So the connectors are the smart contracts that are actually implementing the messages that are sent in between 2 blockchains. So until now, we've got only the state of the synced blockchains and ability to check stuff. And now we are implementing the actual messages that are going from one blockchain to another. So for example, some examples of the connectors. These can be ERC20s that are bridged from Ethereum to NEAR. This can be NEAR token bridged from NEAR to Ethereum, right? Well, and obviously back. This can be ETH. This can be ERC721. This can be DAO resolutions that are working on top of NEAR blockchain and you would like to pass these votes. This can be cross-blockchain calls. This can be anything that you can imagine, right? And again, everything before are the smart contracts on blockchains. That's why anyone is able to build their own connectors, right? If you have some specific information that you would like to pass from one blockchain to another, you are able to do it for free. Because you just can call other smart contracts. You would need just to pay the gas fees. That's it. That's it. That was the hard part. I believe some of you, go in a little bit asleep here. But now we are going to go into some interesting problems on top of this. Maybe you actually have heard a little bit about the Rainbow Bridge before. I'm not sure whether you're following the developments there. But yeah, but let's go to something new, or something that was not widely communicated. It was accessible, but I just would like to put some emphasis on this stuff, right? And first question is the governance. The problem with this bridge setup is that on the smart contract level, what we are doing is that we are verifying the headers, right? And as we know from London hard fork, and there's this madness that is happening with Robson right now, we know that hard forks can change the block structure. Hard forks may change the way how the consensus algorithm is working, right? And what does it mean? It means that the smart contracts must be upgradable. Because in case not, well, then you will need to force all of the bridge users to withdraw their funds and deploy to the new bridge, right? This is just hell. It will cost a lot of money, and it will be just super inconvenient, right? So, well, from my point of view, okay, maybe must is too much there, right? But it is strongly recommended for the smart contracts to be upgradable, right? And in this case, since the header verification algorithm is not the part of the smart, it cannot be accessed on the smart contract level, it means that somebody needs to develop this solution. It needs to be uploaded there, and then somebody needs to vote for the upgrading of the smart contracts. You cannot access this data on the smart contract level. You cannot your smart contracts cannot understand what is the change in the consensus in order to implement it right away and to be able to check the new implementation, whether it is good or not. You just cannot do it. Because of this, you need to have a body that is going to make the governance of the bridge. So we started from the problem that there is somebody in between who is doing the bridging, and now we are ending up in the same situation, right? We need to have a governance body, but you can implement this governance body in a much better way, right? And obviously, the most close governance approach to the decentralized nature of the blockchain is obviously a DAO, right? In fact, we have quite a long roadmap for the governance upgrade for the Rainbow Bridge. There are multiple stages there how we are going to this DAO. DAO is not implemented for the Rainbow Bridge right now. But we are going through it, and we've checked with our community whether this approach is okay. I'm not going to cover all of this. There are lots of things. There are lots of reads. It's not the link to the discussion is here, but you can check out the NEAR community forum, and you will be able to Google their Rainbow Bridge governance and upgradability plan. So the ultimate setup that you can get here with the convenient infrastructure for the users is actually you need to have a DAO on the target chain. because obviously you are bridging things from the source chain, and the reason why you are bridging because you need to lower the cost or give this interoperability features, right? So probably on the target chain it is much cheaper to run a DAO. So the ultimate setup is to have a DAO on the target chain. You need this DAO to vote for the upgrades. The votes of the upgrades are applied to the bridge smart contracts on the target blockchain immediately, or straightforward, in a straightforward way. But the updates on the source chain, they need to be bridged through the existing bridge protocol. So the DAO votes about the new implementation on the source blockchain. And then the vote is bridged to the source blockchain, and then this votes causes the change of the implementation. This is the ultimate setup. None of the bridges at the moment is having it, including Rainbow Bridge. But this is the way how you need to do stuff. This is the most decentralized way how you can build a bridge that is convenient to users, and they do not need to constantly think about moving their funds from one implementation to another one. And now some practical aspects. So, Rainbow Bridge exists right now with a little bit simpler governance, not like that. But let's figure out how to if you're using it, what you can expect from it. So actually, Rainbow Bridge, it was in development starting actually by the previous speaker. Anton from OneInch was contributing a lot into the development of the Rainbow Bridge. Unfortunately, he left. And the development started in 2019, late autumn. And then everything was put in production just this spring. And actually, this is the wrong information. It's not 15th of May, it is 15th of March. So 2 months earlier. There is no intrinsic fees inside of the Rainbow Bridge. We do not charge anything. The only thing that user is paying for is the gas fees. In case you are transferring 100 USDT tokens through the Rainbow Bridge from Ethereum to NEAR, you will get 100 NEAR USDT tokens, right? The only thing that you need to pay for is the gas fees on the both networks, right? The total transacted volume is around 5 million, a little bit more, I believe, because I was composing this deck around a week ago, and even then it was 5.1. So the bridge code was audited back in 2020, but since then there are some changes applied, obviously, and we are now undergoing the next security audit of the bridge, because we obviously understand that this is a super crucial piece of technology for NEAR network. In terms of costs, Rainbow Bridge is quite an efficient bridge, and it does not incur lots of costs associated with the fees for the users. And for example, Ethereum to NEAR transfer costs only 40K ETH gas. It's only twice worse than just sending ETH from one account to another. It is almost the same as just a plain transfer of an ERC20 token. Super cool. So from NEAR, yeah, and this is the cost on the Ethereum blockchain, because costs on NEAR blockchains, they are negligible. The cost of NEAR to Ethereum transfer, where we need to check the proof, and because of this transfer is actually not that simple. It costs more. It costs 330,000 ETH gas. So it's like 2 swaps on Uniswap or something like that. And I was not putting here any numbers in US dollars, because nowadays the gas price and also the exchange rate, it goes crazy. So okay, so you can estimate it a little bit. I'm sure you're pretty used to recalculating gas into dollars, right? Now, what about the transfer time? Remember, I said that the light client of the Ethereum on NEAR blockchain, it is realistic. That's why as soon as we can treat Ethereum block as final, it means that we can validate the transfer, right? We can prove stuff. And usually it takes 5 minutes, right? And this is like with extra precautions and all of the stuff. You can have, 10 confirmations, 15 confirmations. That is enough, right? So this is what we're saying. 5 minutes is absolutely the most, an order of 5 minutes is absolutely the lowest that you can get because of the design of Ethereum blockchain. If somebody is saying that they have built a trustless bridge with the transactions over the bridge happening within seconds, they are lying to your face. It is not a trustless bridge. Okay, so 5 minutes. Near to Ethereum is an optimistic, right? That's why we need to wait for some time for the watchdog to be able to issue a challenge. And because of this, this time can be, it should be long enough. We were doing some math, some modeling on the how the gas price may change there, and we figured out that 4 hours is the lowest amount of time that we need to wait. And right now, Rainbow Bridge is operating with the transfers taken from 4 to 8 hours. So 4 is the absolute minimum. 8 is absolute maximum that you can expect from it. So in the mean, 6 hours. What else? We also have ERC 721 connector under review. Lots of people from the community are developing their own connectors. They are trying to do stuff with it. Yeah, and also one additional thing is that we are extending the prover, the Ethereum prover as a smart contract on NEAR blockchain, to support not only logs, but also state and transaction inclusion provers. And we have a little bit of sugar on top of it, right? So because of the way how the fungible tokens are working on the NEAR blockchain, because of the great NEP 141 standard developed by Evgeny, who is sitting here in the second row, we have an ability not to transfer the funds from Ethereum to NEAR wallet, but directly deposit it into the smart contract and actually do some operations on top of it with a single transaction. You can think of this as a composability of the transactions, while there is not, the strict analogy in NEAR blockchain for the composability, but something like that can happen. So literally, a user can deposit his funds to some kind of smart contract even without having a NEAR account. And this is something that we are heavily using in AURORA as a project, right? So in AURORA, just again, I was promising not to pitch you, so just for your information, right? So AURORA is the project that enables an ability to run Solidity smart contracts on top of NEAR blockchain, and users are able to deposit funds in that runtime, right? In the EVM runtime. The second thing here is fast finalization options, right? So we potentially can speed up the bridging transactions with some people providing liquidity for the fast finalization, right? So in case you see, imagine the following situation, you see that there is a transaction happening from NEAR to Ethereum, because this is the transfer that you would like to speed up. There is a transaction happening, and it is going to be proved at some point in time in 8 hours, right? But you would like to get some premium for transferring, for finalizing this transfer upfront with your own funds. So you can send to the recipient of the funds everything, with except for the fee, and then you can prove to the bridge that you already did it, and the fee will be returned to you. This is something that can be implemented. And with this approach, we can reduce the hurdles of the optimistic bridging, right? We can make it work the fast way. And the last, but absolutely not least, is that because we have implemented NEAR-like client as a smart contract on Ethereum blockchain, it means that the whole Ethereum blockchain becomes a light node of the NEAR blockchain. What does it mean? It means that NEAR blockchain right now, only because of the bridge, is as secure as Ethereum with regards to the retrospective attacks, retrospective reordering, stuff like that. So this design is super beneficial for any target blockchains, right? So I'm showing you the design, not the Rainbow Bridge itself, but the way how to build bridges, right? Okay, lots of good stuff, but there are lots of open problems here. And this is one of my main goals here, to raise these open problems and to gather people to discuss this. And first, and I believe one of the biggest one that is in front of the multi-chain community that we have is the following. Imagine that we have the DAI token on Ethereum, and this DAI token is bridged to multiple chains. So to NEAR, BSC, and Polygon, we have NDAI, BDAI, PDAI, right? The bridged token, the bridged IOU of a DAI on the other blockchain. But what will happen if the BDAI is going to be bridged to NEAR, right? Then we will have the NEAR BDAI, right? The NEAR PDAI. Because in case we have NEAR BSC and NEAR Polygon bridge, we will have these tokens. And actually, moreover, you can bridge the other tokens to the other blockchains, and then you can bridge them again. And in case you have 4 networks, you will not be able to limit the amount of the tokens that you are getting from one specific source token. Are these different clones of DAI on NEAR blockchain actually different? Well, probably yes, because the technologies that like people are relying on when they're using these tokens are also different. So for NDAI, user need to trust Ethereum consensus, it need to trust NEAR consensus, and it need to trust the implementation of the Rainbow Bridge. But what about NPDAI, right? Now user needs to trust the bridge in between Ethereum and Polygon, and then from Polygon to NEAR, right? So there is different set of, well, a stack of technologies that the user is using when they are using these tokens. And that's why they're different. And probably the right tokens should cost a little bit less than the left tokens, right? Just because higher risks involved there. Is it convenient to a user? Well, absolutely no. I have $100 in my wallet. I absolutely do not care in which countries these $100 have been settled, right? I do not care whether it was coming through Japan or directly from the US, right? And all of you are not taking care of it. This is super inconvenient to have different tokens there. And what about metadata? So some of the tokens are actually updating the metadata, and this is pretty common. And specifically to some of the projects, the updates of the metadata is in the core of the logic of the token, like Ampleforce, for example. So what was with the metadata? How you're going to bridge it? What will be the metadata for NPBDAI, right? Is it going to be different from the metadata for the other token? I name it the consistency of the tokens, yeah, or the token consistency problem. You can do it, you can try to solve it with something like a curve approach, right? You have similar tokens, you can introduce curve markets there, but as soon as you have, you know, at least 4 networks, as I said, the amount of combinations is unlimited, and you will just not have enough liquidity to cover all of the trades. So this is solvable as a first step. This is not the ultimate solution to introduce the AMM solution there. Something needs to be done here. It should be something like a cross-chain standard for the token bridging. And this is something I encourage all of the people from the community, from other networks who are building bridges, to come together with us and let's discuss it. Let's make a cross-chain standard for the benefit of the whole industry, right? Now let's go even deeper. How to remove the need for the governance entity, right? Because we started with the multi-sig approach, not that good, but still you need to have a governance entity, but how to remove it? Well, we probably somehow move the header description and the verification algorithm to the blockchain, or do something like that. We need to be able, on the smart contract level, to check whether the consensus algorithm is correct or not. For this specific thing, right? This is the first time in the history of Ethereum when this type of question is actually arising. And nobody was never ever thinking about this stuff. And well, who knows? With this setup, we cannot, with this, like with the current stage of Ethereum, we cannot develop a secure, trustless, decentralized bridge without any governing entity. It is just impossible, right? So maybe we need to change something in the blockchain. Maybe we need to do one additional hard fork of Ethereum to help solve this issue, right? Again, open question. So I'm not giving you here the solution, right? I'm just inviting you to discuss. And what about the security incidents, right? A bridge may be broken, right? There might be some kind of vulnerability discovered. How we are going to deal with it? How do we implement the escape hatches? How the users can withdraw their funds? Do we need to restrict breached assets from moving in between accounts when the governance entity introduced the freeze period, right? This is also something usual for advanced governance. Do we need to all of that stuff? Or maybe we can skip something? I don't know. And I was telling you how to make the fast token transactions, right? In case you have liquidity providers. But how the heck we are going to do the fast transactions of an arbitrary data? People cannot be the providers of arbitrary data, right? So you cannot speed up the data, right? Just like that. So, but it will be super neat to do it, right? So these are all of the open questions. I'm leaving it for you. Let's gather together. Let's discuss. We have some ideas how we can organize this as some kind of discussion club or something like that. But at this stage, I would like to end. And thanks for being with us. And I believe you have lots of questions, so I'm here for the next several minutes to answer them. Thank you, guys. Don't be shy.
Thanks. Thanks for the really good talk. It's kind of mind-blowing thinking about the Ethereum blockchain validating the NEAR blockchain. It's kind of crazy to me. Really cool. But yeah, I was kind of under the impression with XDAI, for instance, that their plan is to sort of slowly introduce like more validators and kind of come up with some sort of incentive scheme for them to like validate it properly. Could you talk about why that's sort of inadequate and why their approach kind of can't work long term, I guess?
Well, from my point of view, as I said, introducing the bridge validators is not like, or at least in my head, is not aligned with the spirit of the blockchain and the spirit of the decentralization. And many projects are going that way, right? And then they obviously introducing the incentives there and so on. But like, it's still, you need to trust. You're not trusting the blockchain, only the consensuses of the target and the source blockchain, but you need to trust something more. Something additional entity, and all of the ideas behind the Rainbow Bridge that we cannot sacrifice this decentralization. We cannot do that stuff, right? In order to be aligned with the ideals that we have. So that is the story behind Rainbow Bridge. That is the story actually behind AURORA, but this is for absolutely another talk. Why XDAI is doing like that and whether it is going to be sustainable. From my point of view, it's just not following it is not fully aligned with the decentralization principles. That's it.
So I'm going to ask some maybe like subtle questions just to have an interesting conversation. So in all optimistic systems, you need to have a large number of watchdogs, because just to give a simple example, if you have a town and you want to steal money from a bank or do something bad, and in the town there are 10 cops, if you bribe all of the 10 cops.
That's true.
So it's really important for you guys to have an economic system where the number of these watchdogs is large and they have to be paid. So how, and I think other people also like Optimism, PBC, they never talk about this, but they have pretty much the same problem. So what's your economic model, and how many of them do you think you will have on average? Like 10, 100,
right.
You know?
Right, the fair answer here would be that right now we are hosting just a single watchdog that is hosted by us. The code for the watchdog is available there, anyone can deploy it and run it. It's just quite a simple process. It is going to cost you something like 10 cents per month or something like that with the AWS setup. So it is super simple. It just every minute checks what is there, and it needs to have an access to the NEAR blockchain, right? So super simple, super cheap. Right now it is what it is, but again, anyone can do this. And I'm with you. I'm with you with the premise that we need to have lots of watchdogs.
So if you have a single watchdog, I mean, it's fine. You guys are like developing your thing. But currently you have a single watchdog. That means that you are controlling everything. No one else is watching. And if you want to steal the money and go to the islands.
No, because in order to steal the money, you need to submit the incorrect block.
Right.
And then after the submission of the incorrect block, you need to this block.
There's only one watchdog which is controlled by you.
No.
No?
So look. Okay, so we are going to go pretty deep into the tech stuff, right? In order for you to submit in order for you to be able to steal the money, you need to prove to the bridge smart contract the fact that there is a transaction happening on NEAR blockchain that is causing into the withdrawal of the funds. And in order to prove the fact that there is such a transaction happened in the NEAR blockchain, you need to create a block that is signed by the validators of having 2/3 of the stake of NEAR tokens, and then you submit this, right? This block. And what you can do there is just you can propose the incorrect block there that is not signed by the 2/3 of the validators, right? Yeah, or like there's some kind of one signature or something like that happening there. In case the signatures are so like you can with the absence of the transaction, you are not able to withdraw the funds. You are able to create some kind of other block with a different order of the transactions or something like that, right? You can do that stuff. But you cannot create a transaction that actually was executed correctly and was introducing the invalid state change without having a big chunk of NEAR tokens in your wallet and be able to work with it. So it is a little bit more complicated thing. But, yeah.
What's the purpose of the watchdog then? Why do you need the watchdog? Then you can remove it, or I mean, I'm just maybe asking too many questions, but
yeah. So, well, I propose we start the discussion a little bit outside because okay. I believe we're running a little bit out of the time. But yeah, still, watchdog needs to make sure that people are not submitting the blocks with the incorrect set of the signatures from the validators. Yeah. Because this is the consensus algorithm of the NEAR blockchain. Yeah. But again, coming back to what you have saying, I'm completely with you. Decentralized set of the watchdogs, making the watchdog as simple as possible without any big hurdles for it, this is the way to go. And yeah, if anyone would like to run the watchdog here, well, first of all, the incentive is in case someone behaving bad, you are going to receive the slashed amount of ETH, right? But also, I believe Rainbow Bridge team and AURORA team as a whole can incentivize you with a little bit of money, so you would be able to set up an AWS instance for you. Yeah. Okay, cool. So thanks everybody.